By the way, we are about to go live. It has some latency of 10 seconds or so, but let me share the link with you as well here. This is a YouTube link. Okay, everyone, we should be live now. Nice greetings to everyone watching us. We have right now 12 people, but I'm sure people will be joining. More people will be joining as we speak. Today we have the second session for the Kubernetes Bootcamp, which will be given by Prem. Mitlesh is here. Tito will be joining, I guess, in a few minutes. Pankaj is here. Zubair is joining also just in a few minutes. So we will go through the part 2. We haven't managed to complete it, the whole bootcamp in the last session. The last session was exactly 1 week ago, last Friday, 2nd of July. Today is the 9th of July, and it's part 2. We will cover the following topics today. Let me see quickly. Yeah, this is the topic is observability. It will be presented by Prem. We will continue with workloads and scheduling, then service and networking, and the last topic will be troubleshooting. We also partially kind of started troubleshoot the stuff during the last session last week. Let me quickly post into the stream plan for today. I hope, yeah, it's kind of formatted as one string, but I hope you can figure it out. Everyone, those dear speakers, if you want, you can say hi, introduce quickly yourself, what you guys are doing. You can start, Prem, if you want.
Okay. Hey, hi, myself Prem, working as an lead DevOps consultant, living and working from Netherlands basically. So okay. So the proper introduction, right?
Yeah,
I've been working as an DevOps consultant for through my work experience. I was handling like a lot of applications on cloud, doing migrations, working on CI/CD stacks, writing scripts, Python, DataOps, and so I have done like, a lot of projects in and out. And in terms of certification on Kubernetes, I have recently done my CKA and CKAD both. So got some good decent percentage in both the exams. And we are here to just share the knowledge what we have gained or what we have to help everyone to clear their certification exam. Yeah, looking forward to share some insights about it.
That's amazing. Thank you, Prem. And yeah, any other speaker, Mitlesh, for example, do you want to jump in?
Yeah, sure. Thank you. Hi, everyone. So I'm Mitlesh. I've been working as a technical service manager, and I have been recently upskilling in the area of cloud and DevOps. So I have done several cloud certifications, and also last year I have done my CKA, and now also I'm looking into OpenShift. So as we are onboarding applications into OpenShift as part of hybrid cloud transformation. So as I have already done CKA, and then I'm also planning to do CKAD. So I wanted to share my knowledge as well with respect to the exam and other topics. Thank you.
Yeah, thank you, Mitlesh. Zubair, Pankaj, any one of you want to jump in and quickly introduce yourself?
Yeah, hi, Karan. Yeah, myself, Zubair. I am an cloud ops engineer working on AWS. I'm here to support team here for organizational work. So all the best for everyone.
Thank you. Pankaj, if you want, you can say a couple of words about yourself.
Yeah, hi everyone. Myself Pankaj Kumar Sharma. I have working in a organization as a server admin. I am preparing for the certifications of CKA and OpenShift certification. Thank you.
Yeah, thank you very much. And I'm Karan. I'm serving this community, trying to help each other, that we help each other, to learn new stuff about cloud technologies, but not only, also related stuff. Yeah, and we have an amazing session today for the bootcamp. It's a part 2 again. The part 1 is recorded on our YouTube channel. You can look it up. Let's then dive deep, I would say.
Yeah. Okay. So this is the follow-up session. We had discussed about a lot of topics in the session 1, basically. So where we discussed about pods and we saw like about deployments. Let me actually look into the content here. And how to configure multiple pods and what is a bit of service and networking, state persistent, basically volumes and so on. And today we're going to discuss about how we can monitor the health of the pod before we schedule something, because that is highly needed, right? So we are in a tougher scenario, or else we are in a DevOps era. We are actually intended to create an highly available or highly resilient application, right? So your application should not go down, or else when you do one deployment, your end customer should not face any lag time and so on. Your application should run like 24/7, and if there is an issue, you have to see some reports out of it immediately, right? And Kubernetes have some inbuilt feature to address all those issues, and so where basically like the health probe pattern defines the application reports health state of your Kubernetes. Yeah. So and also about your pods. So there are like certain things which will be like constantly monitored by your Kubernetes cluster. For example, as we saw last week on a specific static path under etc Kubernetes and manifest, the parts like for example the control managers, schedulers, and what are the other things over there? Schedulers, then etcd and so on. So those sort of part thing will be like literally managed it will be managed automatically, like replica sets and so on. But there are like other items, for example, your pod itself. So how you can actually effectively manage those things, right? So let's take a scenario. You have an legacy application, and the legacy application takes time to start, right? And you need to do certain functions after that, after start. So how you will monitor that start function? So there is a start prop. So you readiness. Okay, so once your application is ready, then you want to do something on fly. So that there is a prop for that, or else you want to constantly monitor whether your application is running or not. So how you can do that? So there is a liveness prop which will tell us, or else which will give us that sort of a support uh, to to actually monitor that part. So that's what we're going to see now, and we're going to see like how we can actually implement it, you know. And so by default, you will have like liveness probe and readiness probe. So the key difference between liveness probe and readiness probe is so before getting into the difference. So in theory, you can actually use both probes in one single manifest file, or else if you feel like okay, you want to have only liveness probe, that is also possible. So it's not always mandate to use everything in one single manifest file. You can also split it and use it, or else you can combine it, or else there are like a lot of factors which you can implement. For example, under the readiness probe, you can but I mean, it applies for both the props, you know. So you can actually see whether a file is created on specific directory or not. So there is an sub commands to it, or else you can also monitor whether you your application endpoint is reachable or not during HTTP gate and so on. So you can pretty much do anything, or else you can just do a simple command to create a file on a specific path, and you can see like whether the file is created, and that ensures that like your part is ready, right? So you can do any of such things. It depends on the implementation. We're just going to cover how this prop's going to help us. Yeah. And so as I said, that the startup prob, it's I always consider this as a separate component because startup prob will be always tested when your part is being before actually doing some functions in your part. The best scenarios will be like, okay, you have a legacy application. The legacy application needs to run. Yeah, and that takes some time before getting into the actual function of it. And that's where you can implement this start prob. So the start prob will start the legacy application upfront on a specific time frame, and once it is done, you can have like readiness prob that ensures that like the particular part or particular process is ready. And then once it is ready, you can actually do your actual implementation. Once you're done with your actual implementation, and once the part is up and running, then you can have a liveness prod which will constantly monitor the part, and it will ensure that part is healthy or not. So this is can be one of an hierarchical scenario. And yeah, let me quickly share my screen and go through a snippet which I have in my board. Okay. So basically, this is an replication controller type. So, but then we are just going to see more about props now. So if I just do this here, there is a readiness prop, right? So what it does, to make it very simple, I will just move this piece down. And let's see here what it does. It creates a replica set, and it just tries to deploy this particular Docker HTTP server application, and it checks whether this prop is ready or not, right? So what happens is, once this particular image is deployed as a pod, this go and hits an endpoint on port 8080 on this specific path, and it ensures that this pod is ready or not. So this actually checks this pod is provisioned correctly or not. Once that is done, it constantly still monitors the same endpoint to ensure the actual health of the pod, right? So if there is an issue, if this specific endpoint is not reachable, then you will get an error message. Yeah, so if you just do like kubectl, describe pod or replica set, and then the replica set name, see in the events, so what is causing the issue. So you will see like, okay, the liveness prop is not so there will be some log message on the liveness prop and so on. All right. And so it's pretty much same for other applications as well. So this is unhealthy application. So basically this is a healthy image, and there is some issue with this particular image, and we are also still monitoring the same endpoint. And when we do this, we can actually see like, okay, this particular the pod is not live, and you will actually see an error. We will be actually seeing this in the examples when we run this, right? And this is the service to export that endpoint. Okay, and to go back to my screen again. Yeah, so I'm going to use Ketchacoda for that. And yeah, so this is the CAD file, and that's what we just saw now. And I'm just going to deploy a specific thing, right? So I'm just going to deploy only the bad front end pod declaration. Yeah. So now if I do like kubectl, this describes replica sets and the bad. Okay. Okay. So it is done. So if you can see here, So this actually tries, right? So the timeout is once again the total period. So the total duration is 10 seconds. So one time it got succeeded and 3 times it got failed. So it retries, right? So until a specific declaration is met. Yeah. And if we still see it here. Yeah. So this is not running. Let's get some logs out of it, right? So this is yeah. So if you actually see here we can actually see this particular pod is throwing an warning error, and it's saying like the reason is unhealthy because the liveness probe, it's the status code is 500. So basically, like when you get 200, it is responsible, and 500 it's like it's a non-responsible report, right? So basically, because of this, the pod got crashed. Now let's actually try to deploy the other image. This is fine. So this is the same thing which I showed you, but in a simple way. Um, so here now, okay, let's give some time to get back the pod. Yeah. So does it get already deployed? Okay, so this is the front end part, and now get the logs of it. kubectl describe pod, and then yeah, front end this. So if we see here, this is same image. Leave about scheduling, because scheduling it has something to do with the scheduler, and you can actually see this under etc manifest, etc Kubernetes manifest file. So if there is some issue with your scheduler part, you can actually correct it from the manifest file over there, or else you can just destroy it and recreate it again, because it is a static pod. It will recreate automatically. And if you see here, this one don't have any issues. And if you also see the liveness probe and the readiness probe declaration, you should actually see it here. So this also retried 3 times. The failure was 3 times and successful was 1 time, but then this one is not throwing any error, right? So because the endpoint is like reporting healthy. So the application is up and running. So basically, like with this declaration, you can actually see the health of the pod, and that's pretty much about it. And this will show it is the same thing. And yeah, so basically that's a whole scenario. So the probes is meant to monitor your pod, and it will actually check the health status of your pod. It will report whether it is actually up and running or not. And there can be like a lot of scenarios which you can append. So for example, in our example, we have used HTTP GET to one specific path and a specific port, but you can also do like, okay, you can monitor and file whether this particular file got created, or else you can create a file to check it. So you can actually implement a lot of other scenarios as well. Yeah. And what is the other topic?
The next topic would be workloads and scheduling.
Scheduling. Yeah. So, Mitlesh?
Yeah.
Okay.
Mitlesh, do you want to continue with the next topic?
Yeah, sure.
Okay, great.
Okay. So the next topic is scheduling. So we'll look at job the scheduler and how scheduling works in Kubernetes and with some examples. Okay. So as we have seen in the first part of this session, that what scheduler does, it finds the right node for scheduling your workload. So it checks which node has the right capacity or which node is perfect for scheduling your pods into. So generally, it does not do the process, but it informs the API server that okay, this node is the right one for scheduling the pod, and then API server does the processing of that. So API servers puts the pods in the right place. So that is what a scheduler does. But uh, now you have different scenarios when you are scheduling. So first of them is when there is no scheduler. So if you don't have a scheduler and then you want to uh, put your pod into one of the nodes that you have in your cluster, then how do you do that? So there, that is called manual scheduling. So in that case, there is no scheduler, and it doesn't find where to put into. So because it is scheduler is not there. So how do you do that? Is using manual scheduling. So I'll just share my screen. Can you see my screen?
Not yet. Let's wait a little bit. It usually takes a few seconds to propagate.
Hello?
Not yet, Mitlesh. We are waiting still for your screen to come up.
Okay.
Maybe try again. It's not coming through.
Okay. I'll try again.
As we wait for Mitlesh's screen, maybe someone can answer the question posted by C-Dash in the stream. What is the role of ingress?
Sorry, I was on mute. Where is that question?
Yeah, the question is, what is the role of ingress?
Okay, so basically you have a service, right? So if you know about service, service is meant to expose your path, right, on a cluster level. Now you want to expose an service to outside world, right? So outside of your cluster, and that's where ingress comes into picture. So basically ingress, consider like ingress, which kind of a service which sits in front, and it can convert your HTTP request into HTTPS throughout that traffic world.
Mm-hmm. Yeah.
Hi, Prema. I do have one query.
Mm-hmm.
I was checking in for endpoints. You said about the endpoints, right? So I can say the pods has a dynamic IP address, and service, as you said, it's exposed to the outside world. What is the role of endpoint here?
Okay, if I get you correctly, so the endpoint of the pod you mean, correct?
Yes. I mean, service is having one IP address. It tries to reach the pod, any of the pod, replica set, any of the replica set. Correct?
Yeah, in theory, based on your declaration, yes.
Yeah. What is the role of the endpoint? What does the endpoint does here
If
in between the pod and service?
Okay, so basically, like, okay, you have multiple parts in a single cluster. Let's keep it in that way. Okay, you are
Okay.
deploying an Nginx application or some web application, and that web application has you are doing a scaling. Okay, so you deploy an application and you want to scale it, so you have like multiple applications. So according to the theory, or according to the concept of Kubernetes, each pod will have its own IP, right? So the pod is considered as an individual server, right? And this endpoint will be a single source of entry. If I get your questions correctly, so if you are asking like what is endpoint, so endpoint will be like single source of entry,
Okay. Okay. So service
and
is
you will
also a
be
single
mapping.
source of entry, right?
Yes, so basically that's an endpoint, right? So you will map your service to one part based on label. So you will use a selector to specify a specific label, and that will connect accordingly. So the IP has nothing to do there. So it basically connects with an tags or labels which you are adding there based on a selector in the service. So service is a
Okay.
separate kind. It's a separate resource.
Okay. Thank you.
Is that your question, or did I understood it wrongly?
No, I think it's I'm fine. Yeah. Yes.
Yeah, it was a great explanation. Thanks, Prem. Meanwhile, we can see the screen of Mitlesh. Mitlesh, if you want, you can continue.
Yeah, sorry, I was having some issue sharing my screen.
No
So-
worries. We filled time really very nicely. So please feel free to continue.
Yeah, so as we were discussing, first thing is the manual scheduling of the pod. So what we're going to do is we are manually scheduling the pod into one of the nodes, because if you don't have scheduler available, so it we don't have any information on how to schedule the pod. So we'll be manually scheduling, and how we are going to do that, we'll see in this a short example. So first thing is we're going to create a pod. Okay, so we already have a YAML file, so we'll run kubectl create, and we'll create a pod. So we have the pod created. We hit the status. It's pending. It's pending because there is no scheduler here. So we have for this example we have deleted the scheduler, so there is no scheduler and it is not able to schedule it. So we have the nodes, we have the machines available. As you can see, we have two machines. One is the master node and another is the worker node. But since there is no schedule, we are not able to schedule this pod. So it says that why it is in a pending state. So as we have discussed, it is in pending state because there is no scheduler here. Okay, now it says we manually schedule the pod on node 01. So we have this node, right? And we'll be manually scheduling the pod in this node. So how we are going to do that? What we are going to do that, we will specify the node name here to manually schedule the pod. So we'll say the node name, and the node name is node 01, and this will schedule the pod in node 1. So we'll modify this. Under spec, we specify the name of the node where we want to schedule. We'll delete the previous pod and then we'll recreate it. You see now, it is now trying to create. After some time, you'll see that it goes to the running state. Wait for some time. Yeah, you see that it is running now, which means it is now scheduled. So we describe the pod. So you see that this pod is now scheduled on node 01 because we had mentioned node 01 as the node name. So this is about manually scheduling. So, but if you have the scheduler present and you don't want to manually schedule because your node, this node which you're mentioning may be down or it may not be available, in that case, you cannot depend on this, that you mention a node name and then you schedule the node onto specific node. So for that, what we have is labels and selectors. I will. So we have seen this manual scheduling and now
added to, sorry,
yeah,
added to this, even the static pod creation on a specific node can be also considered as an manual scheduling. And for example, can you just go back to that terminal and do kubectl get pods -a? Sorry. Yeah, so if you see here, when you actually do create a static pod on a specific server, you can, those particular pods will append the name of the server at the end of its name. For example, kubectl control manager -control plane. So the name of this particular server or host name of this server is control plane. If you can just type host name there, small letter, yeah. So basically this is it, right? And in case if you want to schedule a pod on some node 1, node 2, node 3, just an example, you can still do that. And this is also one of the troubleshooting scenario, right? So you want to schedule a pod on node 2, but your kubectl is not running. So then how to do that? Or else the kube master is not running, how to do that? So you can actually get into the path, the kubelet path, and you can specify your static file path name in the configuration file, and you can spin it up. And then when it gets created, if you do this kubectl get pod -a, it will append the image, the pod name along with the host name. So basically, this is also another type of scheduling.
Yeah, thanks, Prem. So as Prem mentioned, you also have something called static pod, right? So this is mostly the use case of static pod was to, for example, you do not have when you start installing, right? Then you do not have the API server. So how does this scheduling works? So in that sense, when kubeadm initiates, and we have seen in the initial session that we use kubeadm to install, so it uses static pods to deploy this. So whatever you see here, etcd control manager, all are running on the control plane as static pods, because we do not have API server immediately available at the moment. Okay, so the next thing is now we have seen the node name, and the next thing is labels and selectors. So as we understand that with name of the node, it is not a good idea to schedule your pods into, because if it gets unavailable, then we are into trouble, and the pod goes into pending state. So next thing is we can use labels and selectors. So we can put labels, and using the labels we can schedule. So it can be label on the node or label on the pods. So if we can use node selector in that case, so that we give a label to a node, and then we can use the same, and also we can label you can use the label and the selector to select those labels. So I will show that using an example that will make it clear. Is my screen still visible?
No, you can start to share again, and once it's visible, I will let you know. Not yet there. Now it comes through. Yeah, now I can see your screen.
Okay. Okay. So here, if we see, we have, it says we have deployed a number of pods, and they are labeled with a tier, environment, and business unit. So it says that how many pods exist in the dev environment. So we can use the selector here. So this is how we are using the selector. So we already have this labels, and we are selecting. So you can see that this is the label that is given. And based on this label, it is selecting these many pods. And how it is selecting is using the selector. So selector is kind of a filter which uses it to identify which pods are labeled with this. So if
And
I
this
say,
is one of the sorry, and this
yeah,
is one of the key thing in Kubernetes. So it's not only for this, for all the services, irrespective of what kind. So you will be like referring to one kind from another kind, just using the label. So the label will be like effectively used in so many places. For example, so you can schedule a pod on specific node based on an label, or else you can create your pod. Like if you have a two-tier architecture or three-tier architecture, you can create a label accordingly, and then you can map your pods based on the label. So that is possible. For example, the one of the case which we discussed before for the service and endpoints, right? So service, you can create a service, but then the service needs to know like what all the things are needs to be added as a backend pool. So based on this label and label selector, you can effectively handle that.
yeah. So if I see get pods, and then So labels, you can see all this.
I'll let you know once it's once it's working again. Sorry guys, it's first time this kind of glitch happened. Now the signs are good. Let me just confirm it that it works. It's a good sign. Yeah, I think we can. Anyone confirm that YouTube is actually working, or people on YouTube, can they like say that the stream is going on now? It looks good from my side. The stream is going on now.
Yes.
Yes, it's working now. Fine.
So if I say
now it. Okay, sorry everyone for the glitch. Mitlesh, I think we can continue. The stream is going on. Please go back like a couple of minutes before I interrupted you with this technical glitch, and if you could start from there so that we don't lose important information, would be great. Thank you very much, and sorry for the technical glitch.
Yeah, thanks, Karen. So what I was showing and telling that this labels and labels can be applied. It is not just for the pods, but it can be applied to any of the objects in Kubernetes system. So here we have a replica set example. So what we did was we had this. There is an issue. There was something wrong in this labels which was mentioned. So we corrected it, and then we had run it. So we could see that we have a now if we see that, you can see that this also has different labels like environment equal to dev, environment equal to prod, environment equal to dev. So that's how this labels and selectors work. So we have different labels, and based on the labels, you can select which ones you want. So you want to put the labels on a pod and then use it for different environments, for different business units, and so on. And then we have something called and tolerations. Hello, Karen, am I?
Yeah, we can hear you. That you were talking about.
So as we had seen that we when we are scheduling the pods in the first, we did this manual scheduling where we schedule the pod based on a node name. Now that node may either be may either not be available, it may be down, or it may have something called taints. So taints is nothing but it cannot be, a pod cannot be scheduled. What happens is you need to have specific permission to schedule your pods into that node. So it is like, for example, at the moment you have this containment zone boards in your apartment. So in my apartment, I have a containment zone because of the COVID cases, and so I know this is a bad example, but yeah. So this means this tainted. So you have there is a red board outside, which means the entry is restricted, but it doesn't mean that entry for everyone is restricted. The people who are living in the apartment can still go in, which means they have the permission, and that permission is called toleration. So you have the taints and you have the tolerations. So you have the taints, but then some people can still enter in, which means some people have the permission to enter. So for example, the police personnel can still enter in even if others cannot. Again, take you to an example to show this.
You will be sharing the screen, Mitlesh, right? Mitlesh?
Can you see my screen?
Yeah, we can see now the screen.
Hello?
Yes, Mitlesh, we can see the screen.
Sorry, I was speaking. Were you not able to hear me? About taints and tolerations?
Yes, contact for employer. Yeah.
No, I was able to hear you.
Okay. I thought I lost my audio as well. Sorry. Here is an example for taints and tolerations. So how many nodes we have in this? We have two nodes, a control plane and a node, a worker node. Do any taints exist on node 01? So as I was mentioning that if we have a taint on the node, it will make it possible to schedule the pods on that node. So we go and see if we have any taints on the node. So we describe the node. So you say that at the moment there are no taints on node. Put a taint, which means we are going to make it kind of not available for everybody. So how are we going to do that? We create a taint on the node with no schedule, which means pod cannot be scheduled here. Now this node is tainted. And you see that there is a taint on the node.
Outage timing.
And this will not evict the existing part. So the thing is like right with this no scheduler, it will not schedule the new parts. So kubenet will not allow, or kubeap will not allow to schedule a new part, but if you already have one part running on it, it will be still there. So that will not be evicted.
Yeah, thanks, Prem. So now we have created a taint.
Daddy, have you seen that? Where is the dog?
Okay, anyway, I will create a pod. I don't have a
And basically, that is an empty file, I guess.
Okay. It says there is a pod, but
Let me check the different namespace.
I think we're in default only.
No, what I'm saying, do kubectl get pods -a.
Let me reload just a second. I will just reload again. Yeah.
Don't have much questions in the chat right now on the stream. So if you have any questions to the presenters, feel free to post them into the chat and we will address them as soon as we have an opportunity for it. Let's wait a little bit for Mitlesh to join again. And by the way, to follow this, the whole hands-on labs and resources, we have been posting into the chat the link to the document. It's a shortened link with a bit.ly shortener, but it's basically a link to the document various and for the current Kubernetes Bootcamp or parts of it. I'm posting it here again into the chat. You will see it there. Mitlesh, are you there?
Yeah, I mean, until he comes, we can just share some information about the exams, right? So, yeah, I mean, we have created that labs for both CKA and CKAD. If you guys feel like, okay, that can be a new scenario which can be added, please feel free to, yeah, create a pull request and then we can merge it into our repo. That's not a problem. And regarding this tent and toleration, right? So basically, you will get tent and toleration sort of a question mainly for CKA, and where you will be asked to um, drain a node. I mean, there are like, so there will be a question to train your node and reschedule the pods in different nodes, and there will be a scenario. Okay, you need to you need to untend a node, for example, control plane, and then you need to schedule a pod on a control plane, so which is basically a master node. In general, when you do an installation, master called tent no schedule, because it will not allow any other part to get scheduled, but that won't stop you, right? So you can still do your part deployment on that master node. So that is still possible, and you will get like scenario, this set of scenario questions on exam, right? And so one question where you will be asked to filter the names of the nodes which have a specific tent yeah, and then put it into a file. So basically, for those set of questions, you need to be very much hands-on with your with your kubectl output. For example, how you can sort out that output by going through the JSON file. So basically, like, you can print those JSON path. It's not JSON file. So you need to know like how you can pass the JSON path and get a specific parameter out of your whole declaration. So this set of scenarios you need to be very much, so all these things you will learn like when you do like more hands-on, because it will help you in the exams to answer all these questions very easily. Because I had some sort of scenarios like this. So I was asked to print some name of one part to one specific file, and yeah, so basically I did kubectl list. I listed the parts, and then I sorted based on specific parameters which they asked me to do, and then yeah, so all these things are like based on the JSON path commands. So and this is scenarios like where you will be asked to fix the issues on the nodes. So there might be a scenario, okay, your node is down, so how you will fix it? Then you need to log into the node, check your kubelets, and how you want to also check whether the particular Kubernetes cluster is installed using binary or a kubeadm way. So you need to identify that first, and then based on that you need to use your respective commands to do that points on the node, and what all the other scenarios which can come up.
Sorry, guys, I'm back. So shall I continue for a moment?
Welcome back,
Please go
Niklesh.
ahead.
Yeah.
Sorry, it was taking a bit more time. So what we are discussing was we had tainted this node to no schedule. Now we are creating a new pod, and we'll see that whether we have we can schedule the pod in this node or not. We'll just use this simple image and create. So we are creating a new pod, and we'll see what is the status. So it is in pending state because we have a control plane where we cannot, this master node, we cannot schedule any one we have do not have any place to put this pod into. So that is why it is in the pending state. So as it says, it is in our state of the pod is in pending state. So why it is in pending state? Because it cannot tolerate taint Morton, because we had given this taint here, and because of that it cannot schedule the pod. Now create another pod which has a toleration. Now, as we mentioned previously, right, that toleration is a permission to enter into that node. So even if the node is tainted, someone who has permission to go into the node can still get the pod schedule there. So in this case, we are creating a pod with the taint with the toleration set to Morton, which means we have the permission to enter this this pod to enter this node. New YAML file. You can see that we have the toleration set. See that it is not in pending state because it has permission for that node. So it is node 01 even though it is tainted. Taking some time. As you can see, it is in running state. So this has toleration. So this is all about taints and tolerations. Is on the control plane node. So if you see, as we mentioned that by default, we cannot schedule any pods on the master node as well. So let us see if we have anything on the master node. That is a taint no schedule, because of which we are not able to schedule our pods even on master node. Now we can remove the taint. Now if we see that there is a taint here, so to make our pods to schedule on the master node, we can remove this taint so that even the pods can be scheduled on the master node as well. Then and it will remove the taint. So it says that control plane untainted. The pod was still in pending state. Now let us see again. Now see that this pod, which was not able to be scheduled into any of the nodes because of the taint, is now getting scheduled. Why? Because we have removed the taint from the master node, so it will get scheduled on the master node. So that's all about taints and tolerations. Steve, at the moment, Prem, do you want to continue or Karen?
Thank you, Mitlesh.
Thank you.
Prem, if you want, you can unmute yourself. And we actually initially planned that Tito will be taking care of the next part, which is service and networking. But Tito couldn't make it today. So Prem, do you want to jump in for this topic?
I cannot show the demo right now, but I can give the theory of it. The lab, it's there in GitHub already. Maybe yeah, we can have troubleshooting discussion or general discussion now, and then we can take this service and config map, volume mounting, and service account creations and so on. Maybe in the next session, because I think like we missed those things in our context. So what is security context and those sort of things, because all this sort of a question will be coming up in exams as well. And yeah, we missed to mention all those topics in the page. Maybe yeah, uh, another follow-up session if possible. And for now, like we can just discuss on the discuss or share some inputs on the for the exams.
Absolutely. I mean, I'm very fine with this. We can shift to if you want to say something about the topic itself, service and networking, you can. Otherwise, as you suggested, we can just straight go to the troubleshooting part and cover the troubleshooting aspects, and then return to the service and networking in the next session, if you will.
Yeah. So,
It's
for
up to you.
example, in terms of service, okay. So basically, I'm just going to cover the theory part. We have three set of one point. One is like node port and cluster IP, and then what is the other one? Um, man. Okay. So basically, let me explain what I have said now. So node port is nothing but you have a specific pod which got deployed on a specific container which got deployed on a pod, and you want to expose that pod outside, right? So those sort of uh, you will have the port number, which is called node port. So when you do this, the particular part will be exposed on that specific port. And there is cluster IP, so which is like okay for exposing the service outside of your cluster, and you will have an end IP. So that's a IP like which you can actually map to your service and ingress as well, right? That's the other thing. And the service level, what all the other things we have? So we have a network policy around that topic, because network pole is the one which controls the traffic in and out. So both TCP and UDP traffics, and yeah, and before that we have ingress. So ingress is the one which routes the traffic to your cluster from outside. That's the other thing. And these are the things we have in the network layer. And we have DNS, core DNS, which is installed as part of your cluster, which act as an internal DNS to route your traffic outside, and that's one thing. And yeah, you can also have some sort of external plugin providers like Calico or Funnel or some other things, which can also does the same job for you. But in a theory, Ingress is also ingress is also like controlling the outside traffic and those sort of things in a way. Um, and when it comes to troubleshooting, there are like a lot of troubleshooting. So you have power troubleshooting, node level troubleshooting, cluster level troubleshooting, service level troubleshooting, and yeah, even for example, so you have set up everything correctly, but then your services is not reaching. It's not because you have configured your endpoints wrongly, but then it can be also one scenario that your label selector was mentioned wrong. Those are often the scenario of node down, or else the part down, those sort of scenarios, or else you have other things like you have multiple schedulers, and the scheduler is not actually scheduling the parts, such sort of scenarios. And there can be like lot, and which we can actually discuss more in practical session, maybe like yeah, in a follow meeting.
Okay, great. And it would be it for today, I guess, right, Prem?
Yeah, I think yes.
That's nice portion of information for our members to consume, I think, for the current session. Sure to prepare the following topics, and as it seems, we will have another session, same weekday, same time next week, and we will think about the agenda and all the details. And yeah, I can invite everyone to join the next session. join tomorrow so that you can grab your seat. Any other ideas, additions from any speakers, or if there are any questions from the attendees, please post them into the chat. We still have a few minutes to go.
Maybe I see one query on the YouTube.
Yeah, can you read it, Zubair?
Yeah, it says, I have been told we need to do some initial setup during the exam so that issuing commands become easier. As the exam will be time constrained, I'm not sure if this tips helps or already shared last week.
Yeah, so there are like two things. One, either you can create an alias for all the commands which you are using I mean, we discussed this thing in the first session. And I mean, if I want to share my personal experience, I did create alias for so many commands, CKAD, and I did spend quite some time to do that. And for CKA, what I felt was, yeah, I mean, I was very much used to the commands actually. So I had like good amount of experience. I mean, I spent good amount of time on the labs. Because of that, like I got used to all the commands as a whole, and I didn't feel like creating alias for those things, you know. So because I was, I mean, typing the full command was way faster than creating an alias for me, because I need to create an alias when I'm executing that command. So if you feel that would help you, and if you have already practiced it before taking it to the exam, then please do that. But then don't ever try this directly on the exam like the one I did for CKA. Yeah. And on the other side, there is another important command which you will feel like useful is auto completion. For example, when you type like kubectl and de, so de can be like deploy, describe, and everything, right? So you can actually do that when you look at installation. So you can create an uh, you can install an package called autocomplete for kubectl command. It's a batch command which
I
you will
think
also.
I think it was very useful for me as well time during my exam, BAS
Yeah,
autocomplete. I think that will save a lot of time when you don't remember the command. You don't have to go to the documentation, but you can just type the tab and the
I
command
have exactly.
automatically coming.
I
Yeah.
I felt like autocombo was very much helpful compared to alias. And in short, try alias only if you have already practiced with the keyword, something like that. If not, don't try it even for the exam. But I would highly recommend everyone to do the bash installation autocomplete script at the beginning of the exam itself. It will not take much time. And the other key point, it's like, right. So I found this very tricky thing. I felt it very useful for I need to set in context. All this sort of an information will be there in the exam page. So you need not to worry about it, and they will also give you one command how to switch the nodes and how to set the context. And so in case if you want to become a pseudo user, how you need to become become a pseudo user, and all those information you will see it there. And added to that, one important thing is, let's say you will have you need to be very much aware of the config which you are working on. So for each question, irrespective of cluster you are in, let's say you can be on the same cluster or else you can be on a different cluster, but for all the questions you will have this set context option in beginning of your question itself in the exam. So just pay some attention over there, else what will happen, right? So they will ask you to yeah do your yeah do, yeah they will ask you to do something on cluster 1, and you might be already there on cluster 2 or other pair of, you know. So if you do in that way, then obviously your exam result will not be validated, because they will just validate it on a specific cluster and then specific path. So that is pretty much important. and what all other key things we from the exam point of view. Do you think anything else, Mithilesh, other than this?
I don't think so, but one thing was very important. Even I lost lot of points. Was the changing the which
Yeah.
space you are in. So what I did was I was doing this installation, which was given task to install using CubeATM. I installed it and I did all the setup, and then I realized that I was doing it on the wrong place. So then I went
Mm-hmm.
back and then I switched the context again. So it is very important to start of any task, you make sure that the command which is already given to switch context, you run that start performing the task.
Let's say, for example, for the next question, what I did was first I need to upgrade the version of my cube adder, and in the next question I need to do some fixes. No, yeah, I need to do some etcd stuff on second. I was like completely lost because I was like trying a different thing, and then what happened was I saw a hint on the screenshot of the question where they have clearly mentioned like the host name. The host name was master 01 or something like that. Then I looked into that one, and the current machine I was in, and I was on node 1 rather than master. So I just again exited from node 1 and went to master. So this kind of awareness will also help in the real exams. It is I spent like that is one thing, and the other thing was I did spend some quite some time when I was doing specific tasks for upgrading my cluster version. So I need to upgrade my kubectl version, kubelet version, and then kubeadm version. And there is a parameter which you need to actually pass. For example, it basically an ubuntu flavor, right? So when you do like upgrade and then the package version, you need to actually be very specific. Like for example, let's say iPhone XX or iPhone Wo, something like that. You need to be very much specific on those package versioning numbers, else it will not work. So I had some issues with that, and eventually I figured it out. And yeah, so it took some time for me. And that's one thing. There is also another thing, right? So let's say when you install a package, the package needs to get downloaded, right? And it takes time to download that package, and then it takes time to install the package, right? So you guys need to be very much aware of that. And if you feel like okay, this needs to be done fast, just do it first, or else just try to finish all the tasks and then come back to this task and do it. Because down sometimes based on your internet strength, speed, you may also it may also take a lot of time to download a specific package. That could cost you a lot of time, right? That's one other tip which I want to share, or else which I feel like okay, this I should have done it in a different way, likewise. And likewise, what are the other can mm, yeah, I mean, if I have something like I can still add it up on the next session. But yeah, the set of things, so just pay attention for these things, because this may look like very smaller ones, but then in real it has like a lot of impact. And yeah, and try to follow the namings of what they are actually asking you to do. So let's say where they will ask you to create a manifest file or else part declaration file. and if they have given a name, just try to use that. Don't go with a random name, because then you are even though you have created an application, it will not be validated. And try to attend all the questions. It's not that like, okay, when you there is no minus mark. Okay, try to attend all the questions. Your mark will be I think, I feel, because there is no such document like how they are actually calculating. But what I felt was, let's say you are doing there is a question for upgrade your Kubernetes cluster version, right? And you have done half, and you don't have a time to do the remaining. But don't worry, so you will get mark for the half successfully finished ones. And yeah, something of that sort. So let's say if you want to create an ingress, and if you have written the file, and if, even after deploying, if that ingress it's not working according to the expectation, that is still fine, because you have an declaration, and you will have percentage of marks for that. And each question will have its own weightage. And so it depends on your logic, so how good are you, right? So if you want to cover all the high percentage questions in the at the first, you can do it, or else you can also do it at the end. But then then that's on your call. What I used to do was like, right, I used to go from 1 to 10. I mean, blindly. So I just don't go on percentage basis, or else like weightage of the task. So it's totally your call, guys. So whichever way you feel comfortable, yeah, just go with that. And just try to do the hands-on so many times before actually getting into the exam mode, actual exam. Because even though like you know a lot of things from the theory point of view, when you actually sit in the exams, it will really test your things, you know. So you will like, even though you have a lot of knowledges on specific area, you will really like you will be really tested. That's what I felt when I got stuck with this Kubernetes task, you know.
Yeah, thanks, Prem, for this bunch of great advices. Also, Mitlesh. I think the people will value it, you know, whoever is listening. And if you will have any other specific questions after the session, either hold them for the next one, or you can always connect with Prem, especially on our Telegram. You can try your luck as well on Slack. So that's saying that, I think we can wrap up for now. What do you think, guys?
Yeah. We can yeah, see next session, whatever
Yeah.
comes.
Okay, we will prepare the topics for the next session and make sure to attend it, to ask your questions if there will be any. But for now, I want to thank all the speakers. I want to thank all the attendees. It was great again to have another session. And yeah, if anyone has any final words of the speakers, feel free to tell them, and we will finish afterwards. Okay, so with this, thanks everyone again, and see you next time. The next event will be announced within the next couple of days, so watch our event stream. Bye bye, everyone.